Okay, get this. We've got three pretty bizarre tech stories that surfaced recently. So this is our mid-May deep dive into the stranger side of tech progress.
Definitely sounds like stuff worth looking into. Makes you wonder what else is out there.
Absolutely. So three unusual things for you today. First up, how a young chemist is rethinking rare earth element extraction.
Okay.
Then this memory tech claiming speeds like 10,000 times faster than current SSDs.
10,000 times. Seriously.
That's the claim. And finally, the accidental discovery of the first self-forming liquid.
All right, let's dive in. Where do we start? The rare earths.
Let's do it. Marie Perrin, she's a 28-year-old Franco-American chemist. Her work could potentially shake up the whole rare earths and strategic metals industry.
Yeah, and that's needed, right? Because the way we get these elements now is, well, it's pretty damaging.
How damaging are we talking?
You get up to 2,000 tons of toxic waste for every 1 ton of rare earths extracted. Think heavy metals, radioactive stuff. It's bad news for the environment.
Yikes. Okay, so Perrin's solution.
It's described as faster, cleaner, and more sustainable. She's focusing initially on europium.
Europium.
Mm-hmm.
Why that one specifically? I mean, it sounds familiar.
It's key for LED screens, phones, TVs, you name it. Gives them those bright colors. And interestingly, it's also used in euro banknotes.
Ah, okay. But it's hard to get, right, from traditional mining.
Extremely. You have to process just tons and tons of rock ore to get a tiny usable amount. It's really inefficient.
So Perrin's different angle is waste.
Exactly. She looked at old fluorescent lamps, neon tubes, stuff we throw out.
Uh-huh.
And the concentration of europium in that e-waste can be like 20 times higher than in natural ores.
Wow. So turning trash into treasure, literally.
Yeah.
How does her process work?
It's pretty neat. She takes the powder from inside these broken lamps, that's where the rare earths are, and she mixes it in a solution with these special bio-inspired molecules, sulfur-containing ones.
Okay.
And basically, the europium just separates out as a solid, all in one step.
One step. That's way simpler than the old methods, surely.
Oh, yeah. Traditional ways involve lots of steps, lots of chemicals, lots of oxygen interactions. Her method cuts down chemical waste, pollution, energy use, the whole lot.
Makes sense you'd start a company then. Recover, you said, with partners.
Yep, a finance specialist and her old PhD supervisor. They're trying to scale it up.
And just quickly, why are they called rare earths if they're actually quite common in the crust?
It's the separation that's the hard part, the rare part. They're all chemically very similar, so isolating just one element like europium from the others is really, really difficult.
Got it. Okay, let's switch gears to speed. This new memory tech from Fudan University, POLX.
POLX, yeah, phase change oxide, and the speed claim is, well, it's almost hard to believe, 400 picoseconds write time.
400 picoseconds. That sounds ridiculously fast.
Yeah.
How fast is that in, like, normal terms?
Okay, so current fast memory, like RAM in your computer, works in nanoseconds, maybe 1 to 10. A picosecond is 1,000 times faster than a nanosecond. PODX is aiming for speeds way beyond current RAM.
And current SSDs, flash memory, they're much slower. Yep.
Much slower. Microseconds, even milliseconds to write. But the key difference is they hold data when the power's off. They're non-volatile. RAM is volatile.
So POLX is trying to be the best of both worlds. Super fast and non-volatile.
That's the idea. Lightning speed, but it remembers everything when you power down.
How do they even do that? What's the tech breakthrough?
Well, they've swapped out the usual silicon channels in the memory cells. They're using 2D DRAC graphene instead.
Graphene. Okay, heard of that. Superconductive.
Exactly. Allows charge to move incredibly fast. Think of it like an electron superhighway. And they've also figured out how to adjust the electric field, they call it Gaussian length, to achieve super injection.
Super injection.
Basically, it lets them cram way more charge into the storage layer than traditional flash memory allows, overcoming a key limitation.
Okay, so faster materials, better injection. What could this actually mean for, us?
The potential impacts are huge. You could see AI chips without the need for that fast, power-hungry SRAM cache memory. That means more efficient AI.
What about everyday devices?
Imagine laptops, phones, booting instantly, like 0 wait time, and significantly longer battery life because this memory uses ultra-low power.
That sounds amazing. Any other big impacts?
Data centers. They use enormous amounts of power, partly for memory. This could cut that down dramatically. Databases could keep way more active data in this super fast, efficient storage, too.
And strategically, flash memory is a big deal in the chip world, right?
Absolutely. A breakthrough like this, if it pans out, could really shift things. It's a fundamentally different approach.
But there's had to be catches, right? It sounds almost too good.
There are definitely questions. The performance needs independent verification, first off. We don't know about the longevity. How many times can you write to it before it wears out? And can they actually manufacture this cost-effectively at a massive scale?
So still early days.
Very much so. They're still working on the cell architecture, doing larger tests. But Professor Zhu Peng, the lead researcher, is optimistic. He thinks it could really remodel storage technology.
Okay, one to watch then. Now, for our final story. The self-forming liquid. This one just sounds weird.
It really does. Pure serendipity, apparently. A student, Anthony Reich, discovered it by accident.
And the key thing is, it always goes back to the same shape. A vase.
Exactly. No matter how you mix it or disturb it, it reforms into this vase shape.
Right.
Which is, not how liquids normally behave.
Right. Like you shake oil and water, they mix for a second and just separate into flat layers.
Precisely. That's thermodynamics seeking the lowest energy state, minimum contact area between immiscible liquids.
So what did Reich do differently?
He added tiny nickel particles to a water and oil mixture.
Nickel, like tiny bits of metal.
Yep. And when he mixed it all up, instead of just separating back into layers, it formed this stable vase shape. It was so unusual it got published in Nature Physics.
Okay, why? What are the nickel particles doing?
Well, nickel is magnetic. The particles acted like tiny magnets forming chains at the boundary between the oil and water.
Like a fence?
Sort of, yeah, a magnetic fence. But because of the way these magnetic dipoles line up, this fence isn't flat, it curves.
So the magnetic particle chains force the boundary between the liquids to curve into that vase shape.
That seems to be the explanation. They create a structure that holds the liquids in that specific, stable, curved form, overcoming the usual tendency to flatten out.
That is genuinely bizarre. Are there any, potential uses for a self-shaping liquid?
It's very early, of course, but it's definitely interesting for material science. Think about industries that already work with immiscible liquid mixtures. Construction uses bitumen emulsions. Pharma uses various mixtures.
So they might be able to use this to create specific shapes or structures within those mixtures.
Potentially, yeah. Creating unique forms or maybe controlling separation in new ways.
Yeah.
It opens up some interesting possibilities, even if it started as an accident.
Wild. Okay, so that wraps up our mid-May look at some pretty strange tech developments.
We had sustainable rare earths from e-waste, potentially game-changing memory speed, and a liquid that thinks it's a piece of pottery.
Right. It really shows how unpredictable science and tech can be, doesn't it?
Yeah.
You never quite know where the next breakthrough will pop up from.
Absolutely. These discoveries, seemingly out of left field, just highlight that. It makes you wonder what other unexpected innovations are brewing right now.
Definitely something to think about. Well, this has been a deep dive from Le Podcast de Philippe. If you enjoyed exploring these fascinating and sometimes, frankly, weird developments with us, please do help us reach our goal of 1,000 subscribers. We'd really appreciate it.